slides here and ask for questions. I already see Gary's hand up.
Yes, Ravi, I do have a question. Sort of, it's about the whole track, since it's on ontologies and data. I'm wondering if the track is going to address some of the hard problems between ontology and data, such as data interoperability. We've had people talk about the role of conceptual models in doing that. I thought that would be part of this track. We've talked about analysis that's needed to unpack things to enable data interoperability. So I'm just wondering whether that's going to be covered, because it seems important
Yeah.
that a continuity,
Part of it will be
the
covered by
overall track,
Alisa.
overall summit.
Part of it will be covered by Alisa, but the Bollinger talk will be largely on time and time-related parts of ontology. So whatever Alisa doesn't cover, maybe we'll cover in a synthesis session, because we don't have a panel planned for this.
Well, do you agree that data interoperability is one of the big issues between ontologies and data, and therefore should be part of our discussion in a communique?
I took the data to be more generic in the sense of creating things like information elements. There the integration is even harder, because we are crossing sometimes domains when terms overlap domains. So yes, it is a hard problem. We have had one summit devoted to interoperability and one summit on repositories. So we don't know. As time changes, the ontology nature is changing. You see the 9 or 10 ontologies I described. Would you call SNOMED ontology a data integration problem, Gary, or something else? There is no even conceptual data model there.
SNOMED has a slightly different vocabulary than other health vocabularies, and has always been a big challenge, because people are using one and people are using another, how to bring those together. So that gets into harmonization, which was a topic
One of the
that
topics,
we
yeah.
discussed and I talked about. And I guess I expect that we'd have some of a discussion of that within this ontology and data track also, but I don't see that either.
Well, we can include some of it in synthesis, as I mentioned, because other slots are taken. Any other questions?
Corey, do you have some remarks?
Yeah, Corey. Corey and I have worked together for a year or two on common contracts and common government assignments. Welcome, Corey.
Yes, yeah, it's enjoyed the working together. At the beginning of your presentation, you talked about some of the challenges with the more deterministic representations, such as we have with OWL and even advanced systems like common logic. The physics-related issues that you were discussing later seem to be good examples of that, where a lot of that information is maybe uncertain or probabilistic. What, if anything, have you found to be usable and scalable representations, formalized representations that can be used for that type of information at that scale?
Are you talking of high energy physics, let's say?
Yes, I mean, in all of your examples.
Multidimensionality seems to be one of the key areas, in my opinion, that relates these entities, namely particles and resonances, with the various rules and symmetries that they follow. I would not go to the extent of saying the kind of math, but yes, the kind of math that will address that will be multidimensional, and not only Euclidean, but in multidimensional in many parametric senses. That is one thing I have begun to realize. That's one.
And do we have the tools that enable that?
Do we have tools? Yes.
Do we have
We have
the languages and tools that enable that?
couple of them we have. One we have in traditional, like Wolfram kind of math, and the other one is ancient Vedic kind of math. Two kinds of maths that address multidimensionality. And I think perhaps Ken can answer more on that formalism part, but the physics part is definitely we are stuck. We are stuck with single Big Bang business. It's becoming more and more less and less sustainable theory. So either we go to multiple Big Bangs or we bring something else to explain this 75% of what we don't know about matter energy. So, and the high energy is beginning to fill some of those gaps through new particles as relics, as lattices, as point particles, many new theories. We badly need them to explain nature of reality, which is what I call physics. Physics is supposed to take us to real life. Math takes us to real logic, real axioms, real imagination, which drives physics. I hope I can at least partially address what you ask.
Thanks, Ravi.
You are yourself having very great colleagues in physics, I know, who are doing model-driven work with you. But this is a partial answer.
So this is Gary again, if I might ask a question again.
Yes, sir.
Barry Smith and his partner, I'm sorry, I've forgotten the name, argued in that paper that for modern physics, the domain experts, that is the physicists, quantum physics and so forth, don't feel they need ontologies because they have mathematical models that do what they need. And I'm just wondering what your position is on that.
I really enjoyed listening to Barry and Professor Landgrave, with whom he collaborated. Landgrave is physicist. Barry is obviously a philosopher, ontologist, and well-known person in developing top-level ontologies. So they interacted and collaborated on classical physics, and they developed those classical physics related ontologies, and I refer to them here, if you see in my references, right there on this slide. And they do great theories and models of physics ontologies for classical, that is static physics of past, but not the dynamic physics that we address today, which is only a small part of physics, because most of the nature as we experience it is classical physics. We can use classical physics to model weather, for example. But if we are talking of solar flares and solar storms interacting with that atmosphere, we need new physics, but still within the reach of what they described. So, good question, Gary. Thank you.
Well, I would just add that if you accept their argument, and you can look at it in the paper as well as what he said, it's essentially that they don't think ontologies and the type of things many of your slides are on this area, such as the Higgs particle and so forth. They feel that the way we do standard ontologies is not going to help them and do better than the mathematical models they have. And so my point here is if we're an ontological field, do we accept that, or do we have something to counter their argument? And that's a difficult question.
Yeah, I'm going to share only my personal professional opinion on that. I think ontologies can play a part through things like knowledge graph, through things like query within those knowledge graphs, but embedded inside a larger structure of AI, like they did the energy minimization problem in physics that I gave example of. Similar to that, if in the overall solution are embedded ontologies, they might unearth something deep in neural networks that we can't otherwise fathom, because the notion of ontology will create certain patterns within those stores, and we might uncover newer things. This is my personal opinion. I have personally no hands on work on LHC data, for example. But good question, Gary.
Ravi?
Added to it, maybe, sorry, was someone
Yes,
talking?
yes,
Ah,
Alican
yeah.
is talking.
Mhm.
Yeah.
Yeah, it's me. It's me. So my question was that maybe is it something to do with the deduction, in a sense that when you use the physics, then you have already the rules. So for example, if you are Newtonian mechanics, then you have the Newtonian rules. But when it comes to, for example, the usage of me, like when I'm using in the business, there are not such rules, and we are relying on the deductive inference. Maybe do you see the nuisance maybe based on the logic, like use of logic in the physics, and how the rule-based, so to speak, view of the physics and how they contradict to each other? Maybe it was their argument somehow. What do you think about it?
Very, very deep question, Alican. Very deep question. You are not only talking of validity of rules within a domain like classical physics, but you are talking of portability of some of those rules to other domains like finance, like supply chain where you have worked, and so on. And that is a mind boggling proposition, but someday I think we should have the tools to map from one domain like physics into another domain like supply chain. I wish Ram Sriram or Mike Bennett, somebody to comment on this further. But this is as far as I can go. But very, very challenging question. Thank you.
Ravi?
Yeah, Todd.
This is Todd.
Yes.
This is a very interesting talk. Thank you. There's a lot of information I didn't know about. I'd like you to have you conjecture. Might you expect the use of some of these generative AI models based on the data that's being included from the CERN experiments suggest that some of the assumptions, the basic assumptions of physics, for instance, are not necessarily valid?
You mean validate classical physics using the CERN advanced particle data, or
Or
invalidate?
maybe even it could be that, or some of the assumptions they make about space and time are just not valid.
Yes, they are beginning to question those very things that we used to assume. For example, we know that Einstein himself has to transition from special to general relativity for certain situations, right, in cosmology. But we we still have assumed the continuous nature of space and time. And by the way, for everybody else listening, Todd and I have also worked together for a couple of years in the EOSDIS project, when we both shared our work at Raytheon, Hughes, and so on for NASA. Just to recall my past association with you, Todd. But you know much more fundamentals of ontologies than I do. And yes, the rules discovered there will either break the current knowledge of physics or will validate what still is valid in spite of this massive data. And I might also bring our readers to one realization that by breaking, and more high energy is not everything relevant. only some relevant things will come out of this. So, like, we have so much space exploration, but how much good out of it will come is only in terms of realizable economic, environmental, or social values, and not in terms of debris that we are creating in space. So, so this is my, I hope partially it answers you, Todd.
Yes, thank you, Ravi. Now, I want to make one more comment. Earlier on in your presentation, you talked about the ability to use reasoning with data, and that
Yes,
I took that to mean using deductive reasoning, logical inference with data, and
yes,
it is a problem. If your data set is too large, then trying to draw inferences on it, assuming your data is based or has a representation based on some ontology, is a problem. Of course, it's an engineering problem.
yes.
And depending on your data sets, once you get into, terabytes full of triples, you really can't do the type of reasoning you might like to do. So it effectively becomes an engineering problem. How can you partition your data sets so that you can do reasoning, or perhaps we need better ways to develop or better ways to reason, that is deductive reasoning.
Yeah. The one of the solutions that I found that I described in these slides was that if data is well formed, well formatted, and is within domain restricted within the store that you reason on, then you get better accuracy. If it's more fuzzy and distributed across domains, and you are trying to address all that, one thing is your reasoner becomes slow. And second thing is you do take advantage of neural networks, etc., and deep learning. You get little better, but then scalability ultimately catches up with you, is what I have
But
read.
as you
Yeah.
pointed out, using abductive reasoning has a problem in that the answers you get may not be valid. And
Yes,
depending on
yes.
your domain, if you're running a nuclear power plant, for instance, you'd want your answers to be accurate, that is, be
You are
precise, and not allow
absolutely,
for errors to be introduced that way.
you are absolutely right, and things can go haywire if the model is not fit to the data properly. In physics, we call that way. And in ontologies, it would be reasoning, and reasoning, the logic would fail there. I guess it's rule based logic is better than without rules. So, rules and reasoning are somewhat related. Large data and reasoning always have issues, and neural networks help you reduce that divergence but does not avoid it totally.
Yes. Thank you, Ravi.
Mhm. I'm so glad my colleagues and other listeners are asking good questions, and I'm having a good day, Ken, because I'm able uh, to share my views as you all have seen me learn through this forum a
So
lot.
we have some comments
From
from Doug Miles,
yes, Doug, go ahead.
Janet Singer, Mike Bennett.
Mike,
Well, we'll see if I can unmute and actually be heard. Oh, it's
wonderful,
working. Okay.
wonderful,
Uh,
wonderful.
yeah. So I there's a philosopher, Arthur Young, that tried to take things from physics. He had a lot of top domains that weren't really scientific. I mean, a lot of people, got into religion and astrology. But anyway, sticking just to his scientific and math things, he described that a lot of parts could be divided into four concepts or four different distinctions from each other. And then he did that with a threefold way of doing it. So he ended up coming up with like 12 points that you should be able to find in physics that would be ontological. That you could say that they will, I was calling them bindings or tie points in the chat. And it has nothing really to do with physics more than how we describe things to ourselves and to each other. You know, but it ends up corresponding to the equations of physics. So anyway, I feel like there's an ontology in there somewhere. Why those 12 things end up realigning to the other 12 things, to similar things.
Definitely, physics is driven by metaphysics, science in general, and metaphysics and philosophy drive.
Mm-hmm. I guess where I was going is, when you look at the equations, they're reused everywhere. I mean, distance, rate, time, whatever that one. But there's like circular, angular velocity equations that pi gets involved in, and there's nowhere that you're looking at you see pi, but the universe moves like that. And so, are those points of where an ontology belongs things that
Yes.
react to angular motion?
Yes, yes. And we have been only using one kind of coordinate system or Euclidean only. There are obviously many other types of geometries that affect us. And you are right, pi is just one of them. Ellipses are other ways of understanding rather than circles, and so on and so forth. Catenary, uh, the uh, the various other kinds of shapes. Oh, wow. You look at the motion and precision of our planet, the moon, and how to look at the visual area of moon from Earth or the eclipse, etc., the complications. And then GPS, uh, generating a good geo model is itself horrendous in terms of maths. So you are right. it is details. We have to look at other ways. Theta phi r is one good coordinate system where astronomers are happy, and they are happy to talk of parsecs or arc seconds and so on and so forth. Great question. Thank you, Doug.
Mm-hmm.
Mike or Janet?
Yeah, I think this is a good track to bring in the Barry and Jobst issue of the connection between ontology, mathematics, and physics. The issue that they came across was sort of the edge case of, in their language, they said that they couldn't map the concepts in the mathematics that were useful for predictions to common sense entities. And so I think that's a really good thing to keep in mind throughout this track about the data. We can make measurements and we can use the data and we can do things that we don't quite understand. This is another case of the failure of explainability, that when you try to interpret quantum mechanics, for example, you end up with a lot of different conflicting world models. And so anyway, just glad that that's been brought up again, the Barry and Jobst question, because
And
that's sort of...
the very first slide, Janet, first part of your comment I want to ask, it questions how are math and ontology related?
Right.
And when it comes to logic and accurate logic, I sort of see it the way John Sower describes us. And then when it is fuzzy, I get little lost. And they say, even when AI I use to search, that math is one thing and ontology is another. And they're not necessarily the same. So we can't
Right.
say
I guess
one
that,
math
so that issue
accurately.
also came out in, was it Gruninger's presentation about
Yeah.
Hilbert's problem and the mathematics and ontology? So it'd be great to revisit that and keep it in mind. What does a mathematical model have to do with an ontological model? Right.
Very good reference to Hilbert space, because
Right.
all of this physics does assume Hilbert spaces. Of course, he talked of Hilbert theorem, which is different than Hilbert space, but by the same person. So he influenced a lot of areas.
Mhm.
Thank you. Hilbert, Fock, and Dirac. They did, and Wigner. 4
Right.
people. Thank you. And can help me discover one more. In German, it was invariant variants or something by a lady, Noether's
Mhm.
theorem.
Right. Right.
Oh, yeah.
Thank you, Janet.
Mike, are you still there?
Yeah, I'm sorry. It wasn't so much a question, but I was kind of riffing off of something that Douglas Miles said, a choice of language there about having to glue the mathematics to something and binding to things. And this might be part of the answer to how is ontology and mathematics related, which is that actually the interesting question is how is each of them able to be related to reality or to data or to whatever else they're about. So it's sort of like binding with computers. We've been exploring this. Jim Logan has a nice example where you have your name and social security number and so on, and they're all data. Then you walk into like the DMV, the office where you go to register a motor vehicle, and the clerk looks at you and looks at the data and says, yes, that's you. And at that point,
We lost you.
So this is Gary again. I also had a response to the idea of binding. So there are 3 things I think to think in the binding. The original thing that was mentioned was from vocabularies to reality, but in between is ontologies essentially that try to help that bridge, and that takes you into the whole realm of you have a term, you define it, ontologies then try to put axioms to the definitions, and then that is hopefully a good approximate model to the reality, but it has to again be based on the truth makers. We didn't get into that here, but we had prior to it. So the degree to which there's a good relationship, one argument is to the degree to which things like the vocabulary with its definitions as formalized in an ontology map to truth makers or bind to truth makers.
And terms and vocabulary are highly language dependent.
Right.
Thank you.
Also, yeah, so Ken's presentation on the unreasonable effectiveness of mathematics, I can revisit
Yeah.
those ideas, yeah.
Yes. Was very good.
Yeah. Has anybody bothered to look at like data.gov?
Yes.
I mean, talking about large amounts of data.
I
To
think
what extent is it easy to access any of that data? Not just get the data, but make sense out of it. So what does that mean?
Well, 20 years ago, when I was still working and involved in some federal efforts, data.gov got started, and I, along with some others who were involved, said, you know, you need to add some semantics. You can use RDF. And they said at that time, this is a big effort. We don't have time to do that type of thing for now. Maybe we'll get to it later on. I think schema.org is sort of a lightweight approach, attempt to sort of add that. And then we heard from some of our speakers, Giancarlo as an example, about the problems you get when you're too lightweight and you can't really support adequate data integration and harmonization. So, that's where I think we are still.
Yeah, that seems to be where ontologies would be important, not so much determining, the mathematics behind the data, but just, what is this data? I mean, where does it relate to?
Yeah. Or what does it
think
mean as
about
we use
just
think
about
about
15.
these detectors they have at CERN.
Yeah.
The amount of engineering that goes behind those enormous detectors is enormous.
The hope I always had when I was working in these fields in healthcare and other things was that you could at least get a little pilot program to show you the value of this thing. I mean, so they were, spending a fair amount of money. They didn't want to sort of semanticize everything. But if you could take a piece of it and show the value of that, then maybe over time, incrementally, you might get this in there. But that is still not happening well enough or strongly enough. And again, there's a lot of financial issues now.
Yeah, the conversation that you and Gary are having, Ken, is to be addressed really by Corey. Corey, you are familiar with linked open data. You are familiar with CIO's effort from Vivek Kundra and Chopra's times at White House.
Yeah, and data.gov.
And the data.gov, right?
Yeah.
And our colleague at HHS helped us also in populating that. So kindly tell us a little more about that. Thank you.
Well, one thing I thought I had when discussing data.gov, and any of you who have worked on enterprise ontologies recognize it as a social political process, right? It is not a purely scientific one, unfortunately. It involves collaboration and agreement. If you look at something at the scale of data.gov, there is no entity with the agency to organize such a process. And we know the difficulties of political processes in the first place. So one of the things that we lack is the ability to have things to reuse. And while there's been interesting work on domain ontologies, upper ontologies, most ontology efforts start with a blank screen or a very small screen and start to type in words and definitions, rather than bringing them together from some one or set of existing corpuses. And
so to answer Ken and Gary, are these data.gov sites being updated periodically and correctly, or are they kind of disjoint in a way?
They are totally disjoint. They're just generally a set of spreadsheets, largely uploaded, where the columns of those may or may not be well defined. Sometimes they have reasonable English definitions, but there's no attempt for a semantic underpinning. There was, in the original concept, work on bringing them together with some common ontologies, but that has fallen to the wayside. It's just a data swamp for all intents and purposes
Oh my goodness. Thank you. I expected that to happen over time.
Was there originally the belief that a tool like Psych would be able to be used on these things? I mean, without a tool like that, it would be hard to do things with as much data and everything that there is. I mean, is it still?
Very good question, Doug. I'm interjecting in between. I think just as we have LLMs dealing with large text stores. We need to think a little bit about how this plethora of data, which are reasonably, well, somewhat organized, somewhat disorganized, how can we pull? Can AI tools pull something out of them using neural networks or something on data? And that now answers a very big question that Gary had asked in the beginning, is where are we with respect to data and ontologies? So maybe AI would help. I don't know. Any thoughts of LLM like data, something like we do
I am
with
actually
text?
concerned with the over expectation of what LLMs will do for data federation, rather than, there's hope that they will assist, but the
I did not
attitude
mean
in
applying.
enterprises is it's magic and it's just going to solve our problems and we don't have to think about these things anymore. It concerns me.
No, I was not implying that we use LLM model. I was saying something like LLM, but more related to aggregation of data. We were hoping at one time that data would lead to information stores, and has not yet happened fully. Happens in weather, obviously, because we get weather forecast. So there are some fields where it's happening. There's medical directives, so that way health directives, but it's not happening on all data at the federal level in US alone, let alone globally.
Yeah, that raises the issue of the provenance of the data. What were the intentions, the assumptions, the measurement instruments? How is it encoded? All of that side, where ontology would be useful, because it would refer to the human activity that generated the data. So I guess there's really no excuse for not having ontology on that side, as opposed to the mathematical model side.
And we are constantly generating those in, at least for our various departments that serve the government purpose. But Corey has brought the reality to light. I was not updated on that for last few years, so thank you.
Yeah, out of curiosity, I looked up, I did a search for metadata management on the data.gov site, and I got, like 4 hits.
FGDC metadata
Doesn't look
is
like
one
a
of,
lot's happening there.
but do you see FGDC metadata group? Federal government's metadata group?
Um,
No, which is a evolution over Dublin core, I thought.
yeah,
And
Dublin core is mentioned.
is EOS-DIS metadata mentioned?
I'm just, it
Or
doesn't
Earth
seem like
Science?
there's much going on in the way of metadata management for this data.gov
And
resource.
healthcare can use a lot of metadata.
That's just data.gov. I mean, that's not all of science. Anyway, we're running way over time.
Thank you, Ken.
We'll have to continue this discussion later. Thanks everyone for coming.
Thank you,
Ken.
Ken, and all my colleagues who are on the call. Thank you so much. I
Thanks,
Now,
Rob.
deeply appreciate
to
your listening to
next
me.
week when
Yes, Elisa
Elisa
Kendall will be speaking to us. She is from OMG and also thematics. And she'll talk a lot about the gaps that I have in my knowledge that she knows a lot more about. And I've worked with her for a couple of years in OMG working groups. Thank you so much. She will be a very good speaker. I request everybody to advertise and come to listen to her. Ken?
Okay, so please
Back
come
to you.
next week. And with that, we will adjourn.
Thank you, sir.